All right, G, I'm going to show you the syllabus here. जी सबको आवाज क्लियर आ रही है जी? Okay, let me show you the syllabus here and let's begin. All right, as far as the topic of PET scan is concerned, ठीक है, ये PET scanning आपको नजर आ रहा है यहाँ पे, right? As you can see here, all of you. ठीक है. All right. As you can see here, the topic of PET scanning, what we will be discussing is that understand that a tracer is a substance containing radioactive nuclei that can be introduced into the body and is then absorbed by the tissue being studied, right? We'll talk about that. उसके बाद recall that a tracer that decays by beta positive decay is used in positron emission tomography, which we call PET scanning, right? ठीक है. Is that clear जी? सबको आवाज clear आ रही है? All of you जी? Everyone, guys, मेरी आवाज आ रही है आप लोगों को clear? जी हफ्सा, हुजैफा, इनाया, everyone, जिब्राइल, मिनाल, all of you. Okay. Understand that annihilation occurs when a particle interacts with its entire particle and that mass and energy and momentum are conserved in the process, right? We'll talk about that. Explain that in PET scanning, positrons emitted by the decay of the tracer annihilate when they interact with electrons in the tissue, producing a pair of gamma ray photons traveling in the opposite direction. We'll talk about that as well, right? Calculate the energy of the gamma ray photons emitted during the annihilation of an electron positron pair. Understand that the gamma ray photons form from an annihilation even travel outside the body and can be detected, and an image of the tracer concentration in the tissue can be created by processing the arrival times of the gamma ray photons. तो आज हम इस चीज को डिस्कस करेंगे, राइट? ठीक है. Is that clear, everyone? So let's begin. So as far as the PET scan is concerned, we call this positron emission tomography, right? PET scan is known as positron emission tomography. ठीक है. You should know that there are isotopes, and isotopes क्या होते हैं? They have the same chemical properties. ठीक है. जो isotopes होते हैं वो they have, क्योंकि उनके प्रोटॉन नंबर सेम होते हैं तो they have the same chemical properties, right? So they have the same chemical properties, same protons, but different neutrons, right? ठीक है. What happens is isotopes of radioactive substances do what? क्या करते हैं जी? They emit radiations in the form of alpha, beta, and gamma radiations, right? ठीक है जी? Are you getting what I'm saying? कि आपके पास जो isotopes होते हैं, what they do is isotopes of radioactive nuclei emit radiations in the form of अल्फा पार्टिकल्स, ठीक है, आपके पास अल्फा पार्टिकल्स या तो emit होते हैं इन ऑर्डर टू बिकम मोर स्टेबल, राइट? ठीक है, आर यू गेटिंग व्हाट आई एम सेइंग ऑल ऑफ यू? अल्फा पार्टिकल्स, बीटा पार्टिकल्स and gamma radiations. And what we can do is we can detect these radiations easily, right? We can detect these radiations. अब इससे क्या होता है, अब हम ट्रेसर की तरफ जा रहे हैं। यहां तक सबको क्लियर है जी आइसोटोप्स के बारे में एवरीवन? ठीक है, ऑल ऑफ यू, व्हाट आर ट्रेसर्स? ठीक है, ओके, ओके, देन यू शुड नो दैट, सेकंड, ऑलराइट। अच्छा, उसके बाद there's a thing that we call tracer. Now what is a tracer, right? What actually a tracer is, let's talk about that. Tracer is basically nothing but a chemical compound, right? In which one or more of its atom has been replaced by a radioactive nuclei. For example, आपके पास एक compound है, for example, it's magnesium sulfate. Now, the magnesium sulfate here is the compound, and the magnesium of magnesium sulfate has been replaced with radioactive magnesium so that it can go into the body, and the tracer can we can detect the radiations coming out from that compound, right? ठीक है, मैं अभी सर आपको बताता हूँ कि किस तरह से होगा वो। ठीक है, so what is a tracer? You should know that a tracer is a chemical compound in which one or more of its atoms, one or more of its atoms, right, have been replaced by radioactive nuclei of the same element. And that can be used to do what? That can be used to locate or follow the progress of the compound in the living tissue. मतलब वो बॉडी में जाएगा और वहां पे जाके लिविंग टिश्यू में वहां पे आप प्रोग्रेस कर सकते हैं उसको, क्योंकि वहां पे रेडिएशन एमिट होंगी एंड यू कैन सी द प्रोग्रेस व्हाट्स हैपनिंग। इज दैट क्लियर टू ऑल ऑफ यू एवरीवन? जी, ऑल ऑफ यू इन द लिविंग टिश्यू। ठीक है, ट्रेसर यूज्ड इन मेडिकल imaging is introduced into the body by injection or it is swallowed basically। ठीक है, या तो इंजेक्ट होगा आईवी से, इंजेक्शन से, राइट? सो आई एम गोना राइट हियर दैट tracer used in medical imaging is introduced into the body by injection or is swallowed. Again, what happens is then that they travel in the bloodstream Okay, it travels in the bloodstream, and to that particular tissue where it is absorbed. Okay, it's absorbed there. And remember that the choice of the tracer depends on the tissue being studied. Matlab, in your body there are many different tissues and the choice of tracer depends on that. ठीक है, ठीक है, समझ आ रही है? हफ्सा, हुजैफा, जिब्राइल, मिनाल, ताहा, ताजीन, everyone, all of you guys. Is that clear? ठीक है. The choice of tracer depends on the tissue being studied. And since the radiations emitted by the tracer must be detected outside the body, we have gamma uh, emitters, right? Gamma की penetration power ज़्यादा होती है. Alpha और beta उस तरह से use नहीं होते. ठीक है, gamma is used, right? And I'm gonna write here that since the radiations emitted by the tracer must be detected outside the body, what happens is only gamma emitters can be used as tracers, right? Gamma has a greater penetration power than alpha and beta, right? Is that clear to all of you? जी, ताजीन, ताहा, मिनाल, समझ आ रही है? जिब्राइल, हुजैफा, हफ्सा, ऑल ऑफ यू गाइस. ठीक है. ट्रेसर जो होता है वो डिटेक्ट, अच्छा, ट्रेसर की हाफ लाइफ के बारे में व्हाट डू यू थिंक? व्हाट वुड बी द हाफ लाइफ ऑफ अ ट्रेसर? वुड इट बी मोर, वुड इट बी लेस? व्हाट डू यू थिंक? What about the half life of a tracer? Any guesses? Well, the half life should be lesser because if the half life is more, it would harm the people in the surroundings, right? So the half life of a tracer should be lesser. ठीक है, और इसकी हाफ लाइफ अराउंड 2 hours 119 minutes 118 minutes होती है. ठीक है. Is that clear? So I'm going to write here that this is a very important thing, and this has been asked in the past papers as well, right? Tracer has a half life of just few hours, right? It has a half life of just few hours, right? And why it has a half life of just few hours? So that the risk to the patient or medical staff of exposure of radiations is reduced, right? That's why we have a smaller half life for a tracer, right? Now, you should know that although the radiation exposure is a disadvantage, of course, we know that, but it is still better than the surgery. It's comparatively, I'm comparing both of the scenarios. Surgery में biopsies में जो टिश्यूज में से एक्सट्रैक्ट करते हैं उससे ये बेहतर है, ठीक है. Although it's disadvantage, right? But it has its, advantages. So I'm gonna write here that although radiation exposure is a disadvantage of the use of tracer, but this effect is offset by a technique for diagnosis that is non-invasive, right? And does not require a surgery. Or taking biopsies, which means we do not require a sample of tissue to be taken, right? Sample of tissues. Okay? So this is something that you should know by all means, right? I hope this is clear to all of you. यहाँ तक सबको clear है जी everyone? ठीक है? Okay, moving on. I'm going to move towards the positron emission tomography now, right? And annihilation. कि क्या process होता है? What are the equations that are involved, right? As I just showed you here in the syllabus, right? So we have positron emission and annihilation. Positron, और हम देखेंगे किस तरह से अब इसके न्यूमेरिकल्स किस तरह के आते हैं, क्या सिनेरियो होता है. Positron emission and annihilation. Does anyone know what is the meaning of annihilation? Annihilation का क्या मतलब है? जी हफ्सा, what do you think? Jibrail, Minal, Taha, Tazeen, Zephyr, everyone, all of you. What is meant by annihilation? Annihilation का मतलब है complete destruction to, ठीक है, complete destruction हो जाती है और एक नई चीज बन जाती है, right? Yes, elimination you can say. ठीक है, so the positron emission tomography, yes, completely destroyed. Emission tomography, which is the abbreviation is PET, right? Uses radioactive tracer and the tracer used, the tracer that is used in a PET scan, right? Decays by what? Decays by beta positive emission. So there is a beta positive emission involved, right? Okay. So what happens is that the emission बीटा पॉजिटिव जो है वो इमिट होगा. अब आपको पता है बीटा पॉजिटिव कब इमिट होता है? जब प्रोटॉन न्यूट्रॉन में कन्वर्ट होता है, ठीक है. और आपके पास साथ एक पॉजिट्रॉन इज इमिटेड, राइट? एंड वी हैव another thing that is neutrino. This is something that you've done in your AS, particle physics, right? So what happens is the emission of a positron during beta positive decay occurs decay occurs when a proton inside a nucleus is converted into what? Into a neutron. Okay, this process occurs in the nucleus, hence the name nuclear physics, right? क्योंकि न्यूक्लियस से है तो अब ये आगे पार्टिकल फिजिक्स और फिर ये आगे यूज हो रहा है in the medical physics as well, right? So the emission of a positron during beta positive decay occurs when a proton inside a nucleus is converted into a neutron, and this emission also includes neutrino as well, right? This emission also includes a neutrino. So the process is that we have, let's say, fluorine 18 9, right? That is converted into, this is an isotope of oxygen atom, right? 8, okay? And we have E plus 1. ये सारे isotopes are, right? Radioactive isotopes, right? Plus neutrino. So this is a neutrino. And this here is what? This is the positron. So essentially what we have here is that a proton is converting into what? A neutron plus a positron plus a neutrino. आप एक और चीज यहाँ पे नोट करें that the nucleon number is conserved, as you can see here, right? And also you see that the proton number is also conserved. Okay? This is what's happening. One more thing that you should know is that fluorine 18 is very frequently used as a tracer in PET scanning, right? तो ये ज्यादातर क्वेश्चंस जो आपको वो देंगे उसमें यूजली ये यूज हो रहा होगा बट और भी यूज हो सकते हैं ठीक है सो यू शुड नो दैट fluorine 18 is very frequently used as a tracer in PET scanning. The other tracers used are what? Magnesium 23, for example, and sodium. ठीक है इस तरह के डिफरेंट आइसोटोप्स यूज होते रहते हैं राइट अब आपको ये पॉजिट्रॉन इतना ज्यादा कॉमन नजर क्यों नहीं आता हैव यू एवर थॉट अबाउट दैट व्हाट्स द रीजन व्हाई दिस पॉजिट्रॉन इज नॉट प्रीटी मच कॉमन व्हाट डू यू थिंक जी व्हाई दिस uh, positron not very common any idea okay the reason is that this is a very important now the annihilation is going to take place right so within a very short time of a positron being emitted right positron being emitted what happens is the positron slows down right and it collides with an electron which is an entire particle of positron which is what which is an entire particle of positron and now what happens is Like an electron or positron, now they will combine, they will annihilate, and something new is going to form. Let's see what is that, right? So annihilation occurs, as you told me, that complete destruction, elimination, right? All of that. Annihilation occurs when a particle interacts with its entire particle. So when a particle interacts with its entire particle, annihilation occurs. And what happens is the mass of the two particles is converted into energy through the equation. The equation is through the equation, that is delta E is equal to delta m c square, right? The mass is converted into energy in the form of photons, right? आप देखेंगे जो mass था वो photons में convert हुआ है, right? और वो gamma photons है, right? They are what? They are gamma photons into energy in the form of photons. अब ये equation जो है ये, that this is very important, right? You'll see it in a lot of questions as well, that we have E minus 1 0 plus E plus 1 0, which is converted into the gamma photons, right? As you can see here. So these two are what? These two are the gamma photons. Because this is what? This is an electron. This is a positron. And these two are what? These are the gamma photons that we have here, right? ठीक है, सबको clear है ये, everyone? All of you? This is a very important equation that you should know. This was also in your AS level syllabus as well, particle physics. ठीक है? जी, all of you. Okay. Moving on, you should also know that during the process of annihilation, conservation laws are followed as well, right? There are certain laws that are followed. For example, charge is conserved, mass and energy is conserved. We'll talk about that. So during the process of annihilation, during the process of annihilation, what happens is that conservation laws are followed, right? And this can also be asked in the paper, of course. आपको 1 mark का question दिया जा सकता है. Number one is that charge is conserved. The overall charge is conserved. I'm going to show you that. What basically happens is the positive and negative charge on the particle and the entire particle is equal in magnitude, right? And overall charge is zero. You see here what's happening is minus 1 plus 1, they are forming what they're forming, 0, right? माइनस वन और प्लस वन जब मिलेगा तो आपके पास जीरो आंसर आएगा, राइट? ठीक है, समझ आ रही है जी? माइनस वन प्लस वन इज जीरो, तो चार्ज कंजर्व हो गया. नंबर टू, the mass and energy, if we talk about that, so what happens is when the particle and the entire particle collide, right? Since mass and energy are equivalent, the total mass energy before annihilation, the total mass and energy before annihilation must be equal to the total mass and energy after annihilation, right? This is something that you should know. ठीक है, is that clear जी everyone? All of you? सबको clear है? ठीक है. एंड नंबर थ्री इज मोमेंटम इज ऑल्सो कंजर्व, विच इज वेरी इंपॉर्टेंट, और ये अभी हम देखेंगे क्यों इतना इंपॉर्टेंट है. मोमेंटम इज ऑल्सो कंजर्व्ड, राइट? The momentum is conserved. Why the momentum is conserved? You should know that the annihilation produces energy in the form of photons. And since we can assume that, ठीक है, शुरू में उनकी जो आपके पास एनर्जी है वो इनिशियल मोमेंटम शुरू हुआ है, राइट? तो जब बाद में जो मोमेंटम होगा अगर वो जीरो होगा आफ्टर, ठीक है, आफ्टर एनालिसिस, तो एक राइट पे जाएगा फोटोन और एक लेफ्ट पे जाएगा. मैं अभी आपको बताता हूँ. क्योंकि शुरू में मोमेंटम जीरो है, तो आफ्टर एनाइलेशन व्हाट गोना हैपन इज दैट वन photon is going to go to the right and the other photon is going to go to the left. So annihilation produces energy in the form of photons, and since we can assume that the positron and electron collide with negligible initial momentum, since they collide with negligible initial momentum for the momentum to remain zero after annihilation, the resulting pattern that we have, energy, is seen as what? As two photons of equal energy. Okay, they are moving in the opposite direction, right? Of equal energy. The resulting energy is seen as what? As two photons of, equal energy moving in the opposite direction. And what happens is that each photon has momentum. And so the total volume Islam ji, volume Islam. And so the total momentum of photons is zero. ठीक है, तो बेसिकली हो ये रहा है कि आपके पास ये था E-1 0 प्लस E+1 0। ये आपके पास दो गैमा फोटॉन्स बन गए, राइट। और आपके पास जब ये दो गैमा फोटॉन्स बन गए तो आपके पास क्या हुआ कि शुरू में मोमेंटम जीरो था, तो बाद में भी मोमेंटम जीरो होगा। तो एक राइट पे चला जाएगा क्योंकि उसकी वेलोसिटी पॉजिटिव होगी लेट से, और एक लेफ्ट पे चला जाएगा, या एक टॉप पे जाएगा तो एक बॉटम पे, एक राइट पे जाएगा एक लेफ्ट पे। इट गोज ऑन लाइक दिस, राइट। ठीक है, so this is left here, and the momentum is conserved. So zero is the momentum before, and then afterwards m1 v1 plus m2 minus v2 आप लोग इसको कर सकते हैं, राइट, कंसिडर। ठीक है, अब हम इसकी कैलकुलेशंस की तरफ आ रहे हैं। अभी तक मैंने आप लोगों को जो है वो शुरू में बताया कि आइसोटोप्स क्या होते हैं, ट्रेसर क्या होता है, ट्रेसर यूज कैसे होता है, और what happens is that the tracer has a very small half life. ठीक है, we also saw that what is meant by the positron emission tomography, what is the reaction that we have, and we also saw that what are the conservation laws which are being followed, right। ठीक है, इसको हम अब आगे लेके चलेंगे, राइट। ठीक है, क्लियर है सबको यहाँ तक, एवरीवन, ऑल ऑफ यू? ठीक है, सो लेट्स मूव अहेड। यो, जस्ट सेकेंड, जस्ट 1 मिनट, एक सेकेंड होल्ड कीजिएगा जी। अब इसके अंदर सिर्फ कैलकुलेशंस रह गई हैं। लेट्स बिगिन। ठीक है, ओके। ऑल राइट जी, लेट्स मूव अहेड। आई एम गोना डू सम कैलकुलेशंस नाउ, राइट। एंड अब हम देखेंगे किस तरह से आप इसको यूज कर सकते हैं। और डिफरेंट क्वेश्चंस में ये आता है, राइट। ठीक है, फॉर एग्जांपल वी हैव something going on like this, that we have here E-1 0 plus E+1 0. This is being converted into something like this, right? So also, since we can assume that positron and electron collide with negligible initial kinetic energies, what happens is the total energy of these two photons that we have, these gamma photons, the total energy of the two photons must be equal to the energy equivalent of the loss in mass. तो वो मैं भी आपको बताता हूँ कैसे होगा. So for example, आपके पास जो एक्सप्रेशन था वो था ये वाला जो मैंने अभी आपको बताया, that it was e minus 10 plus e plus 10 is being converted into, this is a very important calculation that you'll see. You get a lot of questions, right? So initially we have the mass of one electron as 9.11 into 10 raised to power minus 31 kg. The mass of this is also what? This is also 9.11 into 10 raised to power minus 31 kilograms. अब आप क्या करेंगे कि आप इसी को यूज करके इसकी एनर्जी निकालेंगे in joules, for example. So what we can do is that we have the equation delta E is equal to delta mc square, right? You've seen this equation also in the nuclear physics, right? So what's going to happen is that we have these two electrons, and what's going to happen is that we have the speed of light as 3 into 10 raised to power 8 whole square. And what you get is you get the energy as 1.64 into 10 raised to power minus 13 joules. Now what happens is that this is the energy of two photons in joules. ठीक है, दो photons की energy है, single photon की नहीं है ये. So remember that this is the energy of two photons in joules, right? And what we can do is we can also calculate the energy of one photon as well. आप इसको 2 से divide कर दें तो आपके पास energy of one photon आ जाएगी, right? So the energy of one photon is what? This is the energy of one photon, right? Okay. Now, also you can do what? You can convert this energy into mega electron volt, because most of the calculations that you'll observe would be in, electron volts or mega electron volts, right? Okay. This is a very small amount of energy, so we need to convert it into electron volt or the mega electron volt, right? So what's going to happen is that since one EV is 1.6 into 10 raised to power minus 19 joules, and one mega electron volt is what that is. So what you can do is you can find the energy of the photons, both of the photons in mega electron volt, right? You can easily find that in mega electron volt. So what's going to happen is, so energy of is given by, आपने सिर्फ इसको डिवाइड करना है with 1.6 into 10 raised to power minus 13, sir. And what you're getting is the energy of two photons in mega electron volt. 1.02 MeV is the energy of two photons. And what you can do is you can find the energy of one photon as well, right? How can you find that? 1.02 MeV is the two gamma photons. So the energy of one gamma photon is what? ठीक है, इस तरह से आप एक गैमा फोटोन की एनर्जी कैलकुलेट कर सकते हैं। ये समझ आ रही है जी सबको? ऑल ऑफ यू, हफ्सा, हुजैफा, मिनहाल, ऑल ऑफ यू गाइस। जी बेटा, इज दैट क्लियर टू ऑल ऑफ यू, एवरीवन? ठीक है। अच्छा, अब फर्दर इसमें क्या होता है, दैट यू कैन ऑल्सो कैलकुलेट द वेवलेंथ, एंड दैट वेवलेंथ you'll see is the wavelength of a gamma. ठीक है, आपको आप इसको देखेंगे, जो आपने एनर्जी कैलकुलेट किया है सारा कुछ, इससे आप प्रूव कर सकते हैं कि दिस इज अ gamma photon. So the formula is what? The formula is E is equal to HF. For example, you know that it is E is equal to HF for the photons, right? And आपने energy calculate की थी in joules, which was 1.64 times 10 raised to power minus 13. ठीक है, इसको आप 2 से डिवाइड करते हैं तो एक फोटोन की एनर्जी आ जाएगी, एंड H is the Planck's constant, right? This value is given. ये आपको डेटा में नजर आ जाएगी वैल्यू। ठीक है, शुरू में पेपर 4 के अंदर इट्स गिवन, इट्स 6.63 इंटू 10 रेज टू पावर माइनस 34 टाइम्स एफ, एंड यू कैन इजीली कैलकुलेट द फ्रीक्वेंसी दैट इज गोइंग टू बी, इसको जब आप सॉल्व करेंगे इट इज गोइंग टू बी 1.24 into 10 raised to power 20 hertz. This is the frequency. Then what you can do is you can also calculate the wavelength, and that is given by V is equal to F lambda, right? Since V is equal to F lambda, lambda is equal to V over F, and V is what? That is 3 into 10 raised to power 8, and the frequency that we have is 1.24 times 10 raised to power 20. And what you'll be getting here is the wavelength is 2.4 times 10 raised to power minus 12 meters. This is the wavelength that we're having. And you should know this by all means, that this wavelength corresponds to the wavelength of the gamma photons. Gamma photons. ठीक है, तो इस तरह के आपको क्वेश्चंस काफी आ सकते हैं। ठीक है, एक आपको ये कैलकुलेशन के क्वेश्चंस इस तरह से आएंगे। अब हम एक चीज सिर्फ रह गई है बिफोर वी एंड दिस टॉपिक, दैट इज हाउ टू यूज द पिट स्कैनर इन मेडिकल इमेजिंग। ठीक है, जस्ट अ मिनट, वील स्टार्ट इन 1 मिनट। ठीक है, एक सेकेंड। वील स्टार्ट इन अ मिनट, जस्ट अ सेकेंड, राइट? So finally, I'm going to move towards the idea of a PET scanner that is used in medical imaging, right? So let's talk about that. Okay. How the PET scanner is used in medical imaging, we're going to talk about that, and what are the advantages of that, right? ठीक है. असल में किस तरह से इमेजिंग उसकी बनती है, we'll talk about that. So we have here what we have: PET scanner used in medical imaging. Medical imaging and diagnosis to determine how well certain bodily functions are operating, right? So the tracer that is being used for this is fluorodeoxyglucose, right? आपको वैसे उसका नाम याद करने की उस तरह से जरूरत नहीं है, but they can give you in the exam, so you should know that कि फ्लोरीन का tracer use होता है. So that is what the tracer used is fluorodeoxy, right? Fluorodeoxyglucose. इसको FDG भी कहते हैं. We call this FDG, right? Which is which is labeled with radioactive fluorine. ठीक है, the tracer that we use is fluorodeoxyglucose, right? Now you should know that the fluorine is what fluorine is a positron emitter. It's a positron emitter, right? And I've already told you that it has a half-life of around 118 minutes. ठीक है. Now, why we are using this FDG? FDG is a naturally occurring sugar that does not interfere with other bodily functions, right? It's a naturally occurring sugar. It is a it's a naturally occurring sugar, right? That does not interfere with any body functions. ठीक है, इसका जहां पे रिक्वायर्ड होगा वहीं पे जाके एक्यूमुलेट होगा, स्पेशली कैंसरस ग्रोथ पे ये जाके ज्यादा एक्यूमुलेट होते हैं. ठीक है, are you getting what I'm saying, all of you? Now what happens is that using the radioactive tracer, what you can do is it is possible to analyze where the FDG builds up basically. Or does not build up. Cancer tissues basically they tend to accumulate sugars to a greater extent, right? The cancer tissues that we have, ठीक है, जो जिन लोगों को कैंसर होता है तो उनके टिश्यूज जो है ये इसको एफडीजी को ज्यादा बेहतर तरीके से एक्यूमुलेट करते हैं। ठीक है, और पता चल जाता है यहाँ पे प्रॉब्लम है। अभी मैं आपको इसका डायग्राम बना के दिखाऊंगा किस तरह से आपको पता चलता है कि यहाँ पे इशू है। ठीक है, इस पे भी क्वेश्चन आ जाता है। सो कैंसर tissues would do what? They tend to accumulate sugars to a greater extent. Right? Now, what happens is, again, the same scenario that we have understood here, that we have E minus 1, 0 plus E plus 1, 0. This is forming what? This is forming two gamma photons. तो आपके पास बेसिकली होता है कि ये आपके पास एक ये पेट स्कैनर बेसिकली इट्स अ मशीन विच इज समथिंग ऑफ दिस सॉर्ट, राइट? Similar to the सीटी स्कैन मशीन जो होती है उसकी तरह की मशीन होती है, राइट? ठीक है, इस तरह से। एंड व्हाट हैपेंस इज दैट द पेशेंट इज यू नो surrounded by a ring of detectors. So there are detectors here every now and then, right? This is a ring of detectors, right? So this is a patient, for example, right? And what's going to happen is that the patient is surrounded by, ठीक है, ये बिल्कुल उसी तरह से है कि आपके पास जिस तरह से एक सीटी स्कैन की मशीन होती है उसमें पेशेंट जो है उसको इंसर्ट किया जाता है, तो ये भी एक सर्कुलर मशीन होती है, राइट? ठीक है, बिल्कुल उसी तरह की। सो व्हाट हैपेंस इज दैट द पेशेंट इज surrounded by a ring of gamma ray detectors, right? So what happens is that when positrons and electrons they annihilate, ठीक है, annihilate, what happens is that two gamma photons are emitted. They have the same energy, but they travel in the opposite direction. So what happens is that अब इसका process क्या है जो इस पे question आता है, that what happens during a PET scan, right? The question is that two detectors, if two detectors on the opposite side of the patient, for example, here and here, here and here, like this, right? ठीक है, आपको पता चल जाएगा जहां पे ये इंटरसेक्शन हो रही है, यहाँ पे पता चल जाएगा प्रॉब्लम है, मैं आपको बताता हूँ। सो इफ टू डिटेक्टर्स ऑन द ऑपोजिट साइड्स ऑफ द पेशेंट detects gamma ray photons, then what happens is then it is known as it is known that annihilation took place, right? The annihilation took place along the straight line joining the two detectors, right? Annihilation took place, ठीक है, क्योंकि यहाँ पे आपके पास ये होगा कि यहाँ पे फोटोन डिटेक्ट होगा, यहाँ पे गैमा फोटोन डिटेक्ट होगा ऑपोजिट साइड्स पे, तो आपको पता चल जाएगा कि यहाँ पे क्या हुआ है कि annihilation has taken place, right? What else happens is that, ये समझ आ रही है जी सबको? हफ्सा, हुजैफा, मनाल, ऑल ऑफ यू गाइस? Is that clear? ठीक है. Now what happens is that the detection of this, ठीक है, of this line is stored on a computer. On a computer. ठीक है. And the difference in arrival times, this is a very important line here. The difference in arrival times of the two photons at the at the detector are processed. ठीक है. ठीक है, अगर फॉर एग्जांपल एक फोटोन पहले वहां पहुंच गया है क्योंकि ये इसके करीब था, इस पेशेंट के राइट साइड पे ज्यादा करीब था और यहाँ से दूर था, तो वो वहां पहले पहुंच जाएगा राइट साइड पर. ठीक है, कैंसरस ग्रोथ जो थी राइट साइड पे ज्यादा थी, तो वहां से जो फोटोन एमिट होगा वो जल्दी पहुंच जाएगा. सो उनका जो डिफरेंस इन अराइवल टाइम है of the two photons at the detector are processed, right? And what happens is the image is उसकी image create होती है, उसको process करता है computer and the image is formed. So an image is formed and a PET scan is formed as a result of that, right? ठीक है. The image is, so these are some of the important lines here. They can give you a 3 to 4 mark question here. What happens? The image is built up of the tracer concentration in the tissue, right? उसकी image बन जाती है. And then what happens is a set of data for the PET scan PET scan consists of millions of these lines, which can be processed by the computer to give image of organ or the tissue where the tracer accumulates. So all of this information that you have, ठीक है, ये जो मैंने आपको बताई है डिटेक्शन, और ये पहले एनाइलेशन हुई, उसके बाद डिटेक्शन हुई कंप्यूटर पे, डिफरेंस इन अराइवल टाइम्स का बात आप करेंगे, इमेज की बात करेंगे, और आप ये तो आपको 5 मार्क्स आराम से, यू कैन स्कोर इजली द 5 मार्क्स इन द पेपर, राइट, पेपर 4. ठीक है, एक क्वेश्चन आया हुआ है एग्जैक्टली ये जो मैंने ऊपर कैलकुलेशंस की हैं, एग्जैक्टली डिटो लाइक दैट. That is from March 22, paper 42, question number 11. Also, physics with Cyrus, worksheets have a lot of questions, right? ठीक है, मेरी worksheets में भी I'll share with you guys, right? I have a lot of questions regarding the PET scan and all of that. So this is the end of the chapter, right? And that is all that you need from the medical physics. I've also uploaded the X-rays, the entire X-rays, and the ultrasound as well on my live YouTube stream. ठीक है, that is available there on my channel, Physics with Cyrus, right? So go and watch and share it with your friends ताकि सबका फायदा हो. ठीक है, thank you very much. Allah Hafiz. Allah Hafiz.